Okay, 5.3 definite integrals and antiderivatives, part A. So, definition of antiderivative. A function f is an antiderivative of f on an interval I when f prime of x equals x. They're saying that f, right, uppercase f, is the antiderivative of this lowercase f function if I have to derive this to get that. That's what they're saying. If I have to derive, so I have a function called f, the big F. If I derive it and it equals the lowercase f, then that means that if I take the lowercase f function and I find the antiderivative of it, it'll be the original f of x, the big uppercase. Now, here is the notation, right? This plus c. Let me explain that real quick, hopefully. When we have something like this, right? If I ask you to derive that, you should be like, okay, seeks x. Now what happened to the 4? And see, this is a question that you should be answering. Well, it's a constant, so it becomes 0, hopefully. So yes, it's a constant, so it becomes 0. Now, we're working backwards now. We're going to start with what we're considering basically the derivative, and we're going to work backwards to get to the original equation. Now, the problem with that is, all right, normally we take the what's called exponent, multiply it if there is any number in the front, a coefficient, we multiply it, and then we subtract 1, right? 2 times 3 is 6, and then 2 minus 1 is 1. Okay, if I work backwards, I'm going to, instead of multiply by the exponent and subtract 1, I'm going to go backwards and add 1 exponent, right? And divide. Okay, so let me go backwards. So now I'm doing the antiderivative. So let's see, 6x, I'm going to add an exponent. So that's 1 plus 1, so it's 2. And now I'm going to divide by my new exponent. Okay, I'm doing the antiderivative here, people. And I get 3x squared. Now, what is different from my antiderivative and the original equation? And hopefully you're thinking, oh, well, the 4 is not there. Right. There was a constant in the original equation, but when I worked backwards, I lost that constant. The fact is, though, there could have been a constant there. There could have been a number there. So we take that into account by just automatically plusing c. Okay, we call it the constant of integration, and it's because there could have possibly been a number there, and we have to take that into account. Now, if there wasn't a number there, no big deal. The plus c will just be 0, right? We'll just call it 0. But if there was in fact a number, we are making sure that we're aware that, you know, there could have been a number there. All right. So example 1. So antideriving is just, it's integrating. Integrating is antideriving. And antideriving is going backwards from deriving, derivative. So example 1, I'm doing the integral of 8x dx. So I'm going to take 8x, and it has the exponent of 1. I'm going to add 1, I get 2, and then I'm going to divide by my new exponent. And then, oh, there could have been a constant there, so plus c. Now, how important is this? Very. If you do not write plus c, you get the answer wrong. That's simple. Okay, of course, that can be simplified just a bit. So 4x squared plus c. B, I'm antideriving 2 sine x, or integrate 2 sine x dx. So let's do a little recap here, folks. If I were to derive cosine, the derivative of cosine is negative sine x. If I were to derive sine, the derivative of sine is cosine x. Now remember, we're going backwards. So essentially what we're doing is we're starting here and going this way. We're starting here and going that way. So for b, 2 sine x. Well, this number right here, it's just a multiple. It's a scalar. I can call it scalar. Okay, that's a good word for calculus. Scalar. That number can actually just come outside of the integral. It doesn't have to be in it. I'm still doing this. I need to find what is the antiderivative of sine. Now let's go back here again. We're going backwards. So if I have sine, right, I need to be looking at this one. I need to go back to cosine. But there's a problem. It's negative. It does not exist. There is no negative sine x. It's just sine x. So let's see. If my derivative is negative sine, right, I'm trying to go backwards here. So if I start off with a positive sign, well then maybe my cosine was negative. Right? So 2, and then the integral of sine of x, or the antiderivative of sine x, is negative cosine x. So negative cosine x dx. Okay? Then I just bring the negative to the front. Oh, I'm sorry. I don't need the dx. I don't know why I'm writing that. Okay, so want to check real quick? All right, let's check. Take this and derive it. The negative 2 stays. The derivative of cosine x is negative sine x. Oh, look, the two negatives make it a big fat positive sine x, 2 sine x. Next, example 2. All right, so here we're going to want to rewrite before we integrate, just like when we derive. I'm going to rewrite this as x to the 1/2, because now it's going to be a lot easier to work with. So I'm going to add an exponent, so half plus 1, or 2 over 2, make it the same denominator. So I get 3/2. And then I'm going to divide by the fraction, 3/2. But when we divide fractions, right, I'm going to divide by my new exponent, but when we divide by fractions, we actually multiply by the reciprocal. So 2/3. Okay? That's basically my answer there. I'll leave that. I don't know why I wrote it like that, because normally I don't. Let me fix that real quick. I'm sorry. I got ahead of myself, I suppose. All right, so leave it like that. And then let's move forward. So this stays, right? And what we're doing to it is we're adding a whole to make it 3/2. And then we divide by the new exponent, which is the same as multiplying by the reciprocal. And there's my answer. So I get 2/3 x to the 3/2 power. And if we recall, the 3 and the halves, the top one, the 3, that's an exponent. The bottom one means square root, or a root. Since it's 2, it's square root. So 2/3, and then square root of x to the 3rd power. Okay, and then, of course, what am I forgetting to write, but I mustn't forget to write? Plus c. Plus c. And now that I think about it, I think I forgot it on the other one. For talking so fast. Yeah, I did. Plus c. It really is important. Okay? Alright. B. Same thing. I'm going to rewrite. So this is x to the negative 3rd power. Okay? The negative tells me, oh, it's the exponent. Okay, so I rewrote that. So now I proceed. I have x to the negative 3rd power. I'm going to add 1, which makes it -2, and then divide by my new exponent, and then plus c, my constant of integration. So I have -1/2 square root of x plus c. Okay, recall, this negative means it's the denominator. Okay, the 2 stayed in the bottom. I put the 1/2 up front, no big deal. and then plus c. All right. Example 3. So here we're just integrating a polynomial. And what you're really doing is you're integrating pieces. You're doing 3x to the 4th dx minus the integral of 5x squared dx plus the integral of x dx. And of course, I do not expect you to write this out every single time. I just expect you to do it. Okay, not necessary to do all of this business. But either way, so I'm going to go ahead and write what I already had. 3x4 minus 5x squared plus x. And then what I'm doing to it, I'm adding 1, dividing by the new exponent. Adding 1, dividing by the new exponent. And this one has an exponent of 1. I'm adding 1, dividing by the new exponent. And then, of course, must not forget, plus c. Because there could have been a number there. And then, if I write it properly, so it's 3/5 x to the 5th minus 5/3 x cubed plus x over 2 or 1/2 x squared plus c. All right, example 4. So here we're going to rewrite, essentially, or what's the word? Simplifying. Rewrite or simplify, because it'll do the same thing. I see that I have some x's in common, right? So I'm going to go ahead and I'm going to cancel out x's. X cubed divided by x squared, basically. Right? So I'm just going to write it out, though. I'm splitting up the terms, so I have 2 fractions now. Parentheses dx. Okay, so I've rewritten it by splitting up the fractions. So the x cubed divided by x squared leaves behind 1 little x. And then the 3x squared, or 3 over x squared, sorry, I can write as 3x to the negative 2 power. And now I'm ready to integrate. So I'm going to go ahead and write what I already had written down. So x plus 3x negative 2. And I guess I could just go ahead and throw away the plus c, or throw in the plus c. And then, so add 1, divide by that new exponent. Add 1, divide by that new exponent. And then, like I already wrote, plus c. And there you go. Let me lower this a little. Oh man, I forgot this one's a whole picture. All right, so that stays. So essentially what I have is x squared over 2 minus 3 over x squared plus c. Oh no, it's not squared. Oh my god, negative 2 plus 1 is negative 1. It's just x. It is just x, but it's still in the bottom. Okay. B. So B, same idea. I'm going to go ahead and write it down here. I'm going to split it up. And so x divided by the square root of x. Now, if you recall, algebra 1, this has an exponent of 1, this has an exponent of 1/2, and forget about the square root, right? And the way to simplify that is just to take the exponents and subtract. 1 minus 1/2 is 1/2. So I just have x to the 1/2 power, and then plus, and then so I have x to the 1/2 power, but negative 1/2 because it's a denominator. And all I did was rewrite it. Haven't done anything else. So now I can go ahead and integrate. So I'm going to write down what I already had. And then I'm going to work with that. So add a whole, so 2 over 2, which is basically 3/2. And then add a whole, 2 over 2, which is positive 1/2, plus c. Oh, sorry, and divide by my new exponent. Now, if for the first term my new exponent is 3/2, dividing by that is actually the same as multiplying by 2/3. For my second term, if my new exponent is 1/2, dividing by that is actually multiplying by 2. So what I have is, really, truly, deeply, is 2/3, and then the square root of x cubed plus 2x, but then that 1/2 means it's square root, and then plus c. All right, c. Okay, so here's where we have to remember some trigonometry. For example, sine of x over cosine of x is tangent. 1 over cosine of x, that's the reciprocal of cosine, is going to be secant. Okay, we're going to need these identities for c. So we're going to rewrite this. So first order of business would be to split up. So sine of x over just one of those cosines. And then multiply by 1 over the other cosine, because it's a squared. I'm just splitting them up. Okay, squared just means the same number times itself. Cosine squared x times cosine squared x. So I split them up. And then this is dx. All right, integrating. Well, not quite yet. Remember the, what do you call these? The identities? We're going to use these babies. So now what I have is sine over cosine is tangent, and 1 over cosine is secant. So I'm going to integrate this. That means the antiderivative. That means what do I have to derive to get tangent x secant x? Now it's a little out of order, but the other identity you should be thinking of, or well, it's not an identity, sorry. When you derive secant x, so let me derive secant x. The derivative of that is secant x tangent x. So basically, that's what I have. A little out of order, no big deal. So the integral of that, right there, ladies and gents, is secant x plus c. This is my answer. That's the integral. That's the antiderivative. You want to check? No big deal. It's easy enough to check. Take this and derive it. The derivative of secant x plus a constant is secant x tangent x, and the constant disappears. It becomes 0, right? Plus 0 when you derive. Right. Next. Example 5. Okay, so up to this point, all we have done up to example 4 are indefinite integrals. Example 1 through 4 are all indefinite integrals. They are indefinite because we definitely do not know what they are. We're not for sure what the original equation was. Now, what part of it is the part that we're not sure about? And hopefully, right now you're thinking to yourself, oh, the part that we're really not sure about is this. Okay, notice how I'm back at example 1. The plus c. I don't really know what that is. We're just assuming that it could have been there, so we want to make sure we compensate for that. We take that into account. We acknowledge that there is an existence possibly of a number. So these are indefinite integrals. These are all indefinite. Jump ahead to example 5. So we're going to talk about indefinite versus definite. Part A here. I have the same integral, but one of them is definite and one of them is indefinite. This is an indefinite integral. When I integrate this, I'm going to have to write plus c. Okay, so 3x squared, add 1, divided by my new exponent, plus c. So x cubed plus c. Okay, that's my indefinite integral. Definitely do not know what it is, not for sure, not 100%. Now, down here, this is my definite integral. And hopefully, if you're actually paying attention, just to look at both of them, what's the difference? Okay, so hopefully you're like, oh, this one has limits. Definite integrals have limits. Maybe I should write have or has limits. No, has. Okay. Now the reason that we definitely can say that we know what it is because of the limit. And I'm going to go ahead and integrate this. Now we've already done it, right? We did it on top. So the integral of this is x cubed plus c. Now the limits, they work because we have to actually plug them in. That's how they work. So the proper notation is, you find your integral and then you draw a little line and you're like 4 and 0, and that should be like your sign for, yo, you have to plug these in. So now we do one at a time. So we do x cubed, we do 4 cubed plus c minus 0 cubed plus c. Now notice, I put in the upper limit first. Upper limit first. That does not mean the biggest number first. Nope. The upper limit goes first. Right? So you're going to do b minus a. If this is a and this is b, you're going to do f of b minus f of a. I repeat, upper limit does not mean the bigger number. Okay. So, if you do the math, I'm going to go ahead and get rid of this. If you do the math, 4 times 4 times 4, what's that? 64 plus c minus 0 plus c. Distribute the negative 64 plus c minus 0 minus c. Oh, look what happened here. These c's cancel out. My answer is 64. Look at that. Okay? The definite integral. I know what the answer is. The answer is 64, and I know that for a fact. I don't have to guess at the constant of integration because they cancel each other out. And they always will. And since they always do, when you do definite integrals, I really do not expect you to write plus c because they do cancel out. All right, so b, same idea. Top is indefinite, bottom is definite. So the top, so negative 6x minus 4, add 1, getting negative 3, and then divide by that number, plus c. So my answer is 2x to the negative third power. So really that x goes down here, plus c. Now, for the definite, remember this is definite, because I will definitely know what the answer is. It's the same thing. It's 2 over x cubed. I'm not going to write the plus c, but I am going to write my limits. You have to do that, because that tells me that I have to plug in that 1 and that 2. So it's going to be 2 over 2 cubed minus 2 over 2 to the 1 power. And then this is 2 over 8 minus 2 over 2, which is 1, or 2 over 2, which is 1. But see, my denominator here is 8, so let me help myself out by writing 8 over 8. So then I get negative 6 over 8, and that's my answer. And I could simplify it, but in this class you really don't have to, unless they're multiple choice. You have to figure out what your answer is. So that is the difference between definite and indefinite. Indefinite, we integrate. We have our constant of integration plus c. Definite, we don't need the constant of integration because it will cancel out. They both will. But you integrate and then you plug in your upper and lower limits and you get a number. And remember, this is all, the idea of all of this is that this is basically the area underneath curve. Okay, try it. Go ahead and try it. Pause now if you are actually going to want to try this on your own. All right. A, hopefully you did this on your own. So x squared, add 1, divide by my new exponent, and I get x cubed over 3, but I have to evaluate it from 0 to 3. From 0 all the way to 3, so that means I'm going to plug those in. So 3 cubed divided by 3, oops, that's a minus, not an equals, minus 0 cubed divided by 3, which basically, it's just 0. 3 cubed is 3 times 3 times 3, so it's 27 divided by 3 minus 0, 9. Okay, B, a little bit of trigonometry. Okay, B, hopefully you caught this. When I derive x, hopefully, right, if you remember, you're like, oh, the derivative of x is 1. So I'm working backwards. The antiderivative of 1 would be x. So this is x plus, and then, okay, cosine x. So what's the antiderivative of cosine x? What do I have to derive? What do I have to derive in order to get cosine x? And hopefully you're thinking, oh, sine x. If we derive sine, we get cosine. So sine x, and then from pi to pi over 2. So I'm going to go ahead and plug those babies in. So I get pi plus sine of pi minus pi over 2 minus sine pi over 2. And then I still have to give you that unicircle quiz. Any day now. This is pi. This is pi over 2. Square root of 2 over 2. Square root of 2 over 2 is my coordinate there. And then my coordinate on pi is negative 1, 0. And remember, the x is sine or cosine and the y is sine. So back over here. So I have pi plus the sine of pi is 0, minus, let's see, pi over 2 minus the sine of pi over 2, which is square root of 2 over 2. Simplify. I have pi minus pi over 2 plus square root of 2 over 2. And then this is basically, I have a whole pi minus half of a pi. That just leaves me with half of a pi, right? A whole minus half plus square root of 2 over 2. And there's my answer. Yes, that's my answer. Nothing else. Example 6. Okay, so here are some rules we're going to go over. And we're going to go over them with just numerical integration. Okay, just numbers. There's no equation here. I'm telling you what the integral equals. So given the integral of f of x from 2 to 6 dx equals 10. And the integral of g of x from 2 to 6 dx equals negative 2. So find the following. All right, so A. I have two functions, and I'm adding them together. And like I did example, what was it? Example 3. This is basically saying the integral from 2 to 6 of f of x dx plus the integral of g of x dx, oh yeah, from 2 to 6. This is basically saying the same thing. I could split them up, and they already told me that this baby right here is 10, and then this baby right here is negative 2, and then do the math, 10 plus negative 2, and that's 8. All right, b. The only thing with b that's special is this number right here. It's a multiple. We're multiplying by 3, also called scalar. I will use the word scalar, so get used to it. That's an S. Holy smokes, that's horrible. Scalar. All right. The rule for multiples is, or scalars, they can be brought out to the front of the integral. They don't have to be inside of the integral. You do not have to integrate a number you're multiplying by. You can, you just don't have to. So I can rewrite this as 3 times the integral of f of x from 2 to 6, or dx. Same thing. And if we recall from the top, this is equal to 10. So 3 times 10, 30. All right, next. A couple other things to go over. Same numerical stuff, but different one this time. They've told me, given from 0 to 5 f of x dx is 12, the integral. The integral from 5 to 7 f of x dx is 3. Find the following. All right, so I want you and I need you to pay attention to the limits here. 0 and 5. And then we have 5 and 7. Okay, they're different. They are not the same. Okay, importante. All right, so for the first one, they're telling me from 0 all the way to 7. They did not supply me with anything that goes from 0 all the way to 7. But they did give me from 0 to 5 and then 5 to 7. So I can add them up to get my answer. Basically, this integral can be made up of from 0 to 5 f of x dx plus from 5 to 7 f of x dx, because the fact is it's covering from 0 all the way to 7. And then to find my answer, all I have to do is, okay, the first one is 12, and the second one, according to the given information, is 3, so 15. B. The integral from 5 to 0 f of x dx. Again, I need you to look at the limits. It's really, really important. What happened to the limits? Somebody please look at this and tell me what is different about the limits from here and from the original one that has from 0 to 5, or has the limits of 0 and 5. Hopefully you see that the 0 is no longer on the bottom, it's on top, and the 5 is on the bottom. So now the 0 is the upper limit, and the 5 is the lower limit. When limits are switched, all you simply do is, the original answer for this was 12. With a switched limit, it becomes negative 12. And that's it. All right. Oh, I am missing a part. I knew there was more. I'm sorry. Where are my part C's? They totally disappeared. Oopsie. All right, I'm going to go back. A, B. Where is C? Does anybody see C? I don't see C. Okay, no big deal. I still need to go over it. So back to example 5, part C, 2 and 6, and f of x plus 2 dx. All right, so this one, you can split this up. That's basically this plus the integral from 2 to 6 of 2 dx. Now you're probably wondering, well, hold on. You want me to integrate this, but you didn't actually tell me how much it equals. Right, because that you should be able to find. Remember, this looks like this. 1, 2, and then let's say this is 2, and let's say this is 6, and this is 2. Um, this is the equation of the graph, or the graph of the equation. We would be finding the area from 2 to 6 right there. Okay, it's a rectangle. So it's 2 units high and 4 inches wide, or 4 units wide. So my area here is 8, because this is 4 and this is 2. 2 times 4 is 8. So I have my answer for this. It's 8. And then from above, let's see, what was that? It was 10. This part was 10. So my answer, 18. Okay? You should be able to find whole numbers. It's always going to be a rectangle if it's a whole number. Next, the C, which I apparently totally didn't even copy down. I don't know what's happening here. C, you have this. Now this time, of course, I need you to look at the limits. And hopefully, you're very observant and you notice that the limits are exactly the same. Well, when that happens, you didn't go anywhere. Just look at it that way. You didn't go anywhere. Your answer is 0. Okay? That's like having, here's 7. It's going from 7 to 7. I didn't go anywhere. Can't find area. I need a length and a width, right? I need more. Right. That's it. Here's your homework. Please do as much as you can at home. See you in class.